Hello students, welcome to our channel MathLogic, and today's video is about how to use integration or integral calculus to find the area enclosed by different curves and area enclosed between given curves. So let's see with an example. Y is equal to x square is one equation and is the equation of one curve, and y is equal to 2x plus 3 is equation of another curve. We have to find the area enclosed by the region of these two curves. And what is the first step in this case? You have to find the points of intersection. That is the very first step you have to do. How to find the points of intersection? At the point of intersection, both the curves will be having same value. Therefore, x square and 2x plus 3 will be having the same value at the point of intersection. Therefore, you can say x square is equal to 2x plus 3, and if you equal these two things, we get x square minus 2x minus 3 is equal to 0. This is a quadratic equation. So let's factorize by splitting the middle term. We get x is equal to minus 1 or 3. And x is minus 1, we have the value of y is equal to 1, and x is 3, value of y is equal to 9. This is by substituting them in any one of the equations we get. The next step is you have to sketch the graph. Here we have this graph, the region enclosed by the between the curves, between the curves. This is the thing which is required for solving this problem. However, I am just drawn the area enclosed by two curves separately for your understanding. So let's how to sketch a graph of the given curves. First of all, you should know what type of curve it is. So y is equal to x square, of all of us know it's a parabola, and vertex at origin and symmetrical about y-axis, and coefficient of x being positive, it opens upwards. So keep all this in mind, and choosing this coordinate is very important in this. So always keep or have the points of intersection as by default the coordinates of the given graph. For example, here the points of intersection is minus 1 and 3. So minus 1 means here minus 1, 1 and 3, 9. So we have 2 points of intersection here. So minus 1 comma 1 and 3 comma 9. So you have this minus 1, 1 and 3, 9. Also have 0, because we will get the y-intercept, so that it will be convenient for you to plot or draw the sketch of the graph. So having just got or understood how to choose the values for putting the coordinates of a graph, now just use the coordinates and plot the graph. So what is the area enclosed by these curves? So now let's talk about the limits. See, the points of intersection are the limits for our integral. What is the points of intersection? Minus 1, 1, 3, 9. But we will be taking only coordinates of x coordinate and set it as limit of the integration. Y we will see in the next step. So having known that minus 1 and 3 are the limits of the integral, so just draw one vertical line from minus 1 till the that curve. Again, similarly from 3, just go on drawing till it touches the curve, and the region between x-axis and the curve is the area enclosed by the set curve or the respective curves. This is how we find the area using integral calculus. Similarly, in case of straight line, just draw the line, and the limit is same, minus 1 and 3. Just draw one vertical line here and draw one vertical line here, straight, and the area in between, this is the x-axis and this is the curve in case it's a straight line. The area enclosed between these two, the x-axis and the curve, is the area enclosed by the respective curve. So now clear, no? Now we will find out the the area enclosed by or enclosed between the curves. For that, what we have to do is, we know this is the area of one is the area enclosed by the straight line, another is area enclosed by the parabola. You should know which one has a greater area. How will we know? Or that we can do by finding out which is the upper curve. Which curve is the upper curve, that will be having a more area. How to do? In this case, visually we can see that straight line is the upper curve. But we'll use that values we have and ensure that what we have done is correct. Meanwhile, we will go to the step 3. We have to fix the limits of the integral. I already discussed the limits of are the points of intersection, and that too the x coordinates of the points of intersection are the limits of the integral proposed to be used for finding the area. So we have minus 1 and 3. Why we are taking x coordinates already discussed. We are integrating the variables x dx because the function of x is given in terms of x only, variable x. So then how to find out the upper and lower curve and construct the integral? See, at the point of intersection, both the curves will have the same value. So f of x is equal to x square and f of x is equal to x plus 3 will have the same value when at x is equal to minus 1 and 3. Of course, we know it is 1 and 9 for y. However, any value between the points of intersection, it will be having different value, and which curve assumes the greater value, that will be the upper curve. For example, we will put one value which lies between the point of intersection between minus 1 and 3. For example, let us take 0, it's easy to compute. Then f of x square is 0 and f of 2x plus 3 is 3. So this is parabola and this is line. Therefore, the straight line is the upper curve. So now let's construct the integral. The required area is equal to integral minus 1 to 3 2x plus 3 dx. This is the equation of the line, minus integral minus 1 to 3 x square dx. This is the equation of the parabola. Now it's a normal routine way of applying antiderivative and just solving, and we get area is 32 by 3 square units. Hope you would have understood the basic concepts of how to construct an integral, how to set the limit, why is it that the coordinate of x are taken as the limits, and why do you want to find out upper and lower curve. All these things would have been clear. Still, if any doubt, please reach us at jmethodologic@gmail.com or in the comment section. Our team is always eager to clear all your doubts, and stay tuned. Best wishes, students. Have a nice day.